Okay, so now we have done with the entire theory part of the motion chapter. We have also discussed certain numericals in our previous class. Today, continuing the same, we will be doing some more questions on motion. So let's take the first question of today. A boy runs for 20 minutes at a uniform speed of 18 km per hour. At what speed should he run for next 40 minutes so that average speed comes out to be 24 km per hour? So we have been given speed for certain part of the motion, and we have been given time for the next part of the motion, and average speed is being given to us, and we are supposed to find out the speed for the remaining part. So let's start. Very first, what's given to us? So time is being given, that is t1, that is 20 minutes. So if I convert minutes into seconds, that will be 20 into 60, which comes out to be 1200 seconds. Then we have been given the velocity for the first part, that is 18 km per hour. Now as you know that the conversion factor for kilometer per hour to meter per second is 5 by 18. So 18 into 5 by 18, which comes out to be 5 meter per second. The next we have the time 2, that is 40 minutes. Now if I convert 40 minutes into seconds, it will be 40 into 60, which gives us 2400 seconds. Right, now average speed is being given to us, that is 24. So average speed is 24 km per hour. Again, converted to meter per seconds, it will be 24 multiplied by 5 by 18, which gives us 20 by 3 meter per second. Now as you can see, we have average speed values here, we have both the time values, but we don't know the actual distance yet, and we know that average speed is total distance upon total time. So you know this question, total distance will be first part distance, speed into time, that is 1200 into 5, right? But we don't know the part distance of the next part, so let's take it as x. So x multiplied by 2400 and divided by total time. Total time is how much? 1200 plus 2400, which comes out to be 3600. Right? So we can just simplify it, and the answer we get is 7.5 meter per second. So in this question, what we have was, time was given for some part of the distance, that was 200 seconds. Then we have been given the speed for that particular part, that was 18. We have converted to meter per second, which comes out to be 5 meter per second. Then we have been given 40 minutes, the next part of the journey. 40 into 60 gives us 2400 seconds. Average speed was already given in the question as 24 km per hour. Again, we are converted to meter per second. 24 into 5 by 18 gives us 20 by 3 meter per second. Then we know average speed is equivalent to total distance upon total time. So total distance is 1200 into 5 plus we don't know the next part distance, that's why we have taken as x. X into 2400 divided by 3600, and this would be equivalent to your average speed, that is 20 by 3. So just doing your simple mathematics, doing the cross multiplication, we get the result as 7.5 meter per second. I hope this first question is clear. Now let's start off with the next one. Okay, in the meantime, just go through the solution of the first question, and how we have done it. And is there any other way that we can solve this question? Please do share in the comment section. Now, next question we are starting. So next question is, an electron moving with a velocity of 5 into 10 raised 4 meter per second enters into a uniform field and acquires uniform acceleration of 10 raised 4 meter per second square in the direction of its initial motion. So what is being given here is initial velocity is being given, and we also provided the acceleration value, with what value the electron is accelerating. Now what we are supposed to do? We are supposed to find out the time in which electron would acquire the velocity double its initial velocity. Means whatever velocity it is moving initially, we have to double it, and we are supposed to find out the time for that. And then second, there is one more part for this question. How much distance the electron would cover in this time? We're supposed to find the distance as well. Right? So let's begin. That's our question number 2 for today. So initial velocity is being given to us as 5 to 10 raised 4. 5 into 10 raised 4 meter per second, and acceleration is 10 raised 4 meter per second square, right? And we know that v is equivalent to u plus at. Now, according to the question, it's been mentioned that velocity has to be doubled. So, in place of v, I must take 2u equal to u plus at. Just rearranging the terms, we have u is equal to at and time will be equivalent to u divided by a. I hope it's clear up to here. And just putting the value. U is what? 5 10 raised 4 and a is simply our 10 raised 4. So this comes out to be 5 seconds. So just in 5 seconds, the velocity of the electron will be double of its initial velocity. Now the next part of this question, we are supposed to find out the distance covered by the electron. So as you know, the second equation, S equal to ut plus half at square. Now just putting the values. Now initial electron is moving with 5 10 raised 4. So that will be here 5 into 10 raised 4. Time is how much? 5 seconds. So 5 plus half. Acceleration is again 10 raised 4 as given in the question itself into t square. So time is 5. 5 square will be 25. Again, just doing your simple mathematics, we get result as 37.5 into 10 raised 4. 37.5 into 10 raised 4. Now since this is the distance, so unit will be meters. Right? So in this question, initial velocity was given to us 5 10 raised 4. Acceleration was given to us 10 raised 4 meter per second square, and we are supposed to calculate the time in which velocity gets doubled. So for that we have taken v as 2u, double of initial velocity, u as the initial velocity, at as your expression. Now since you want to find out the value of t here, so we just rearrange the terms. U coming to the left side get reduced, 2u minus u gives us u equivalent to at. So here t will be u divided by a. Putting the values we get 5 seconds. Now you're supposed to find out the distance as well covered in those 5 seconds. So you use the second equation, ut plus half at square, 5 into 10 raised 4 multiply by 5 plus half into 10 raised 4 into 25 gives us 37.5 into 10 raised 4 meters. Now the next question. In our upcoming videos, we will be doing lot more questions and raising a difficulty level as well, so that in your exams you can do any type of numerical based on this motion chapter. But what you have to do is just be consistent. You have to follow me. Now let's move to the next question now. Question number 3 for today's class. Now the question is, an object starts from rest. Whenever something starts from rest, initial velocity is 0. So u is equal to 0. Then it travels 20 meters in first 2 seconds. So in time t1, 2 seconds, the distance covered s1 is 20 meters. Now for next part, that is for next 4 seconds, for t2, that is 4 seconds, the distance covered is 160 meters. Okay, now what you're supposed to find is what will be the velocity after 7 seconds we have to calculate, right? Initially object is at rest, it has been given. For time 2 seconds, distance covered is 20 meters. For time 4 seconds, distance covered is 160 meters. And you're supposed to calculate the velocity after 7 seconds from the start, right? So let's begin. So using the first equation for calculating distance, s equal to ut plus half at square. Just placing the values, we get distance as 20, u is being given to us as 0 plus half into a, we don't know yet, and time is given to us 2 seconds. 2 square will be 4. So just doing the simple calculations, we get value of a as 10 meter per second square. Oh, this is the value of a that we get for the time 2 seconds for the first part of the question. Since the object is same, so acceleration will remain the same. Now we are supposed to calculate the velocity after 7 seconds. So we know the formula, that is v equal to u plus at. Initial velocity was 0. Acceleration we just calculated 10, and for 7 seconds into 7. So this comes out to be 70 meter per second. So velocity of the object after 7 seconds will be 70 meter per second. So let's repeat. Since it was given to us, the distance is 20 meters for 2 seconds. Object started initially from rest and it is accelerating uniformly. That is important. Now since distance is 20, so as we are replaced with 20, ut factor becomes 0 because u is 0. Half into at square. A we don't know yet, that's why we have placed a only. For t it is t square. So time was 2 seconds. 2 square will be 4. So we get a is equal to 10 meter per second square. Now since we have to calculate the velocity for 7 seconds, so we will apply the first equation. V equal to u plus at, 0 plus 10 into 7 gives us 70 meter per second. Alright, I hope this question is also clear. Now we'll do the next question or the last question for our today's class. Okay, now the last question. The question is, a motorcyclist drives from A to B with a uniform velocity of speed 30 km per hour and returns back with a speed of 20 km per hour. He is supposed to find its average speed. This question is quite easy. The object is started from certain point A, it is going to point B, and then is coming back to the same path back to point A. According to the question, he is going with a speed of 30 and turning back with a speed of 20. And you are supposed to calculate the average speed. Just look here. So what we are given here is ongoing speed and turning speed. The average speed formula we know, it is average speed is total distance upon total time. Now since we don't know the distance, right? So let's consider distance as x. So x distance going, x distance returning, that will be 2x. Correct? And time. The ongoing time will be distance upon speed. So distance is x upon speed, that is 30, plus distance is again x and speed this time 20. Fine. Now just solving it further, we have 2x. Now LCM of 30 and 20 will be 60. So we will write as 60. Correct? And then just operating it, it's 2, it's 2, it's 3, it's 3. So that will be 2x plus 3x, that is 5x. So average speed will be 2x upon 5x into 60. X cancel out each other. We have 5 times 1, 5 times 2, 12 times 2, 24. So we have 24 km per hour as the average speed for this object. Right? I hope all the questions of today's class are clear to you. Many more questions to come. So see you in next class.